So, this is what we should have done yesterday, but we never got to it because we were distracted by stories. We got to know what to do when we got to do it all. It's like a supreme pizza. It's got it all. Just cheese. That's it. Just cheese. Nothing else. For real? I watch everything but onions. Don't throw in onions unless you cook them till they crusty. But not like I choose new edges. Okay. Here we go. Today, what's today? The 4th? That's what it says. Now, this problem is just like number 24. But it's a nicer 24 because I'm starting with a positive exponent. We got to differentiate, which means just what? Find the derivative. If it says differentiate, you just have to find the derivative. Hey, what is that 2? What's going to happen to the 2 when you find the derivative?
You're going to multiply the 5.
Just shove it to the front or go on and multiply it to the 5 because that's what you're going to do anyway. Hey, find the derivative of this. You don't need me to go. Come up, look up here. Because I know we were all talking about this problem. Jay Will, how do we do this problem? You may not.
Well. You bring the 5 exponent around to the front.
Yep.
Multiply it to 2.
Okay, good. All right, go ahead.
And you leave what's inside the parentheses as it is, but you lower the exponent by 1.
Okay.
And then you multiply it by the derivative, which is negative 2x.
Yes. How many of you missed that on that problem? What was that problem? Kim, what was that problem? Was it yesterday's homework that had one like this, or it was? A lot of people, you missed this part. You just put like x. Or how did you get the negative, Miss Perry? Well, we got the negative because it's negative x squared, right? So the derivative of that is negative 2x. Very good. What can I multiply now? What can I move around? Scramble. The negative 2x, the 2 and the 5. So what's 2 times 5 times negative 2x?
Negative 20x.
I love y'all. Seriously, sincerely, I love y'all. I hope you know that. You guys are great.
Yes!
You know why? It's because you're all so nice. I love this class. I am so thankful that I got to start my time here with y'all. Some of y'all, I started my first day with y'all, didn't I?
Yeah.
Here we go. What do you think? How many of you had that? Hands up. Easy?
Yeah.
That was easy. Okay. You know, we got to start with, we ain't even standing up in the crib yet. We still just laying there. Going, yes. But now, you've learned how to jump out that crib. And you don't need to be jumping out of that crib. We're not very happy. But we just gonna jump right on in there. Okay? Or jump right on out of there. What do you see? Talk to me and tell me what you see. You see I see an X. Okay? I see a problem. What do you see? What else do you see?
You can multiply that 3 times x.
Do you mean, because I need to make sure I understand what you're saying. Do you think do this to distribute? No. Say it again.
Bring down the x and then bring down your 3.
Oh, you mean with this?
Yeah.
Okay. How many functions do you see?
2.
Oh, there are 2 functions. What's the first function? The x is your first function. Now look, hear me out. Just for your notes, write this stuff down. I don't expect you to do this for your homework. I don't. Okay? But just for your notes, you're just learning this. Okay? Where's your second function? This right here is your second function, right? So I have one function multiplied to another function, right on? One thing multiplied to another thing, and you're going to expect me to find the derivative? Well, which rule am I going to use?
Yes!
That's right. We are going to use product rule. Because I'm multiplying two functions. That's FDS plus SDF.
Yes.
Okay. Now this is where it gets a little crazy.
But why didn't you do that on the first one?
Pardon me?
Why didn't you do that on the first one?
Because my first function, if you will, was a constant. And I will use the constant multiple. Just take it to the front, leave it alone. Okay? If it's a plain old number, leave it alone. But if it has an X or anything in combination with an X, you want to use product rule. Okay? Deanna, I probably could go back and use product rule, but when I find the derivative of that first function, what's the derivative of 2? 0, and it's going to wipe that whole section out of the product rule anyway. So we'd still get the same answer. Okay? All right, here we go. What's your first function? F prime. You better list these correctly. Don't just leave it blank. We're finding the derivative. F prime. First function is x. What's the derivative of the second? Now here's the kicker. I have a quantity raised to a power. How do I find the derivative? Which rule do I use? Chain rule. That, or the big picture power rule. Okay? Which is the chain rule. So, what is the chain rule on that quantity to the third power? Who's got it? Go, KJ.
Oh.
What's the chain rule on this right here?
Chain rule on that right there?
Yes, sir.
Well, Miss Perry.
Yes, you do. Yes, you do. Come on.
I was somewhere else.
It's all right. Go ahead. Big picture power rule. Go ahead.
Oh, 3. But you got 3 in the front, right?
That's right.
Okay. Then you 3x minus 7. You only got a 1.
That's right.
Lower it by 1, so it's gonna be squared.
That's right.
Then your derivative of the inside is 3.
Rock
That's
on.
it.
That's what. Am I done?
No.
Don't make fun of me. Plus, what's the second function?
Ooh.
Oh, see, this is the part we might forget. Don't forget about that plus SDF. The second function is that quantity to the third power, isn't it? What's the derivative of the first? 1, that's right. Can we clean that up?
Yeah.
Yes, okay, be very careful. Yeah. Yes, we can. Here we go. First, bless you. Can't you? Listen, please. What do we really have here? Do I have a monomial, a binomial, a trinomial? I really just have a binomial if you think.
Pentanomial.
2 terms. It's a lot of stuff, but it's really just 2 terms, okay? What's x times 3 times 3? Okay, so 9x times this thing plus that thing. Now, say what, Tim? Where's the GCF out of this binomial? The quantity. The quantity is 3x minus 7 to the what power? Squared. Okay, be careful. What will be left in the first term?
9x.
And
Plus the quantity.
9x for the first term plus, my bad, what's the next one?
3x minus 7.
To what power? All right, it'll be to the first power. Now I want you to think about that. Can I make it look nicer? Yeah, anything to the first power is what? It's that, what y'all said. So I'm going to take away the parentheses, and can I make that look even nicer?
Yes.
I mean, now, she's got a good looking dress on. We're about to accessorize. We're about to make her look real good. We're going to tie everything together. Simplify. What's it going to be? 12x minus 7. And that is our f prime, our derivative. Holy moly.
Is there an easier way?
No. No. That's it, honey.
Yeah.
Okay? Because we took out the GCF here. All right, look at it as our first term and our second term. Get it? Everybody cool? Any other questions? Alderman, you good? Yep. Any other questions? JC, you good? All right, let's try another one. Now, does this kind of make you throw up in your mouth a little? Little bit.
In my first block, we had this little boy throw up in a trash can, and then another dude followed him and threw up after him. In the same trash can. I was like,
I can fix that. I do not, for whatever reason, I do not want to use quotient rule. I do not know why. I hate the quotient rule. It's in the form of a fraction. It's too much stuff. It takes too much room, but I don't like it. So move it to the top and use what rule? Product rule. And I want you to just think about it. And you guys are getting a little better about it, but you're still making careless mistakes. You're forgetting one thing every single time on quotient rule. What do you forget? What is the easiest part over that low? That. So how would I rewrite that, y'all? Okay. Now, I want you to work with somebody close to you, and I want you to knock this problem out. So we got to get to that answer. How are we going to do that? Where's our first function? X. And then we've got that quantity for our second function. Right on? Product rule. All right, first function is x. Pay attention. Look. You're going to miss it. What's the derivative of the second Sierra? The derivative of the second function.
is it negative 1/2?
Hold up. Time out. Shh, listen. You thought what?
I thought you brought over the exponent first.
I think negative 1/2.
Negative 1/2 times x squared plus 1.
Well, this is my first function. And now I'm going to find the derivative of the second. My first function is x. So now I'm going to go with chain rule. Right? So go.
Negative 1/2 times the quantity x squared plus 1. So negative 3 for 3 over 2 now.
That's right. Negative 1 minus 2. And negative 3. Good.
Times 2x.
Okay. Are we clue? Are we clear? Are we clear on that? Yes? Okay. Plus, what's your second function? That quantity. And what's the derivative of the first? 1. Did we get the process line? How many of you got the process line? All right, that's really good. The calculus we're getting correct. It's the algebra and the fourth grade math that we're kind of messing up all over. Okay? So the calculus is good. I need you to take your right hand, and I need you to take it across your body to your left shoulder and pat yourself on the back. Because that's good stuff. The calculus is correct, folks. Here we go. We got to make this pretty. Now, what are we looking at? A monomial, binomial, trinomial? What are we really looking at? I'm looking at a binomial. Here's your first piece. Here's your second piece. Folks, that might help you in keeping everything separate. How am I going to make this first piece pretty? What am I going to do to it?
2x.
I got x times negative 1/2 times 2x, right? So, what's 1/2 of 2? 1. And then what's x times x?
Squared.
And then it was a negative, so it's actually negative x squared. Do you see how I think through that? Does it make sense? Yeah, okay. Plus, anything times 1 is that thing.
We gotta cut that line.
Is that an acceptable solution?
That is an acceptable solution. Okay? Now how are we going to make it look better? All right, now look. Oh, look, Kiana went. It's going down to the denominator because it's negative, and that's where it should be. So get ready to write it. In the denominator, that's a long word.
You wouldn't take it out.
Watch. Watch what happens. Okay? If I take it out as a GCF, I'm going to have to go right back to this. Remember, my answer was 1 over the quantity x squared plus 1 to the 3/2 power. So watch what happens. Move it to the bottom, which makes both of those exponents positive, right? What would be left in the numerator of the second part of this?
A 1.
A 1, okay. Very good. Now, I have 2 fractions, don't I? And then when I add fractions, I have to have what? Like denominators. Okay? Like denominators. I got 3 of these terms. I got 1 of these terms. I need how many in both? I need 3/2 or 1/2? Don't I need 3/2? Okay. All right. Stay with me. Stay with me. Exponents. We are thinking about exponents. What is going to give me a 3/2 from a 1/2? When I'm
A 1.
what?
A 1.
A 1, but I'm talking in fraction terms.
2 over 2.
A 2 over 2. So I actually need to multiply 2 over 2, 2 over 2. Don't I actually need to multiply that? If I multiply it to the bottom, I have to multiply it to the top. Okay? So what's going to be left in my numerator for the second piece of this expression? X squared plus 1. Y'all, 2/2 is what? To the first power. Anything to the first power is that thing, isn't it? Do I have to put parentheses around that? No. Watch. I got 2 fractions, like denominators. Holly, what am I going to do? I'm going to add them together. I'm going to smush them. I want 1 numerator over 1 denominator. Do you see it?
Yeah.
Isn't that kind of cool? It is. It is kind of neat.
No, it's not.
Tim, don't be hateful. What happens to the x squared, y'all? They cancel. And then heck yeah, look at here. I mean, if I really wanted to make her pretty, what am I going to do? Put it under. Is it going to be square root or cube root?
I mean, square root.
Square root, the quantity to the third. Right on? Shut the front door. Holy moly. Can you do that? Yes, you can. Yes, you can. Look at that. That is maybe the hardest little.
Oh, I feel we're all.
It does make me happy because practice makes progress. Where do people? I don't know. Or do you guys? I mean, now let's look up here, look up here. Look. Stop it with that. Look. You know practice makes progress. You better participate. I know you don't want to do this work.
Yes.
But you're going to.
Oh.
Oh, yes you will, because if you don't, then Mama's going to be upset. And you're going to because y'all are so nice. You are so nice. So you going to do this assignment?
Yes.
Liar! You are going to do the assignment. Here we go.
Do we have to do?
You know what's supposed to be here in the morning?
You think it will be?
I hope not.
I was going
I do not want no more snow. No more snow. Say snow one more time.
No.
Work together, y'all. Come around the wagons and work together.